for a very long time, and then I just got bored. And I got invited to lead an engineering, an IT team. And I went, yeah, fine, that'd be great, it'd be fun, do some DevOps. And I learned a lot about DevOps, and I do talk about DevOps because I learned a lot. The biggest thing I learned was the horrible situation that we all have around security and cybercrime and stuff like that. And so I went off and talked about that. Java developers, like all developers, want to see the code. So this talk is going to have code in it, right? So it's about vulnerabilities, and I'm going to take you through all the aspects, okay? We're going to talk about really boring stuff about how people manage vulnerabilities and what are things attack vectors. We're going to do that. We're going to do the scary stuff. If you don't get this, see me afterwards because we'll chat. Right? You don't go home unless you're scared. And then there's code. Yes. Everybody wants to see code. Why? So let's start with, well, what's Java vulnerability? Okay. Here we go. This is a diff. This is good. Okay. It's good to see on this one. You can't see it because it's cuddly, and it's the one I want to point to. So I'll go over here. Okay, so it's a diff, and you can see the difference between that line and that line is 2 characters. So don't worry about what it is, just focus on the fact there's a couple of characters. What was this? Well, it was an interesting corner case. It got reported 2001, and what happened was, well, if you had a particular number, and you asked Java double to parse it, it would go through an infinite loop in your machine gun attack. Okay? It's just one of those things, really. But it turns out it wasn't a corner case. It turns out, when the bad guys get their act together, that it's a denial of service attack. Because if I post things to you, I send headers, you know what they're like, web server, I send headers. If I've got one in there that's got a double, right, and it's that number, then your web server does some parsing, gives it to parse double, and it loops. Ta-da! Infinite loop denial of service attack. This problem was been around for ages, was rediscovered in 2011. And there's the URL, you can go and read all about it. But basically, trivial to explain, I just have to post to your web server, as long as you're running Java. And all these people went, that's fun, ScriptKid is, anybody who could actually construct the get brought in what's happened. And everybody did this. And in 2011, lots and lots and lots of servers went down because of that. Everybody was doing it. So you can start off by saying that vulnerabilities, if anything, are bugs which get exploited. Right? So that's a good definition to start with. But actually, if you think about them, it's the exploit. It's a vulnerability that gets turned into an exploit. Somebody figures out that you've got a problem, which we'll talk about more, and they do 3 things really. They can attack your availability, denial of service, bring your system down, and you would have read about denial of service attacks, but maybe you didn't realize how easy it is to do it to your application. It reduces your integrity. Ways of getting into your system, so I can attack your data, I can change your data, I can get you to run code, I can do bad things on your server, and breach confidentiality. Well, I can get privilege escalations. What that means is, can I find a way of getting into your system to get full access? Because I can do magic stuff, and I can steal all your data. Right? That's basically what somebody's trying to do. What are all of these things? Now you may go, I don't care, I'm just a developer. Not my problem. So, let's talk about reality. as I said, this talk started because I learned things. It's like in the movies where they suddenly discover that aliens are real or something. It's like, oh, and that happened to me, and I'm going to share it with you. So lots of people think cyber criminalists are lone hackers. You know, you've heard how they've been described as this kid, 15-year-old, in his bedroom, popping coke and just eating crisps and doing this. Right? And yeah, it's true, they exist. But they're not the ones that we worry about. Right? You might think it's obvious when you get hacked. You notice. Right? But actually, what these guys really want to do is make sure that you don't notice. Right? So it's not what you think it is. It's not like they're going to try and come in and hack your website and say, we own this. No, it's a lot more sophisticated. A lot more sophisticated. I'm just going to ask, I've got slides in here and I don't know where they came from. Anyway, let's see what happens. Do you think you would be too smart to be suckered? This is an email I got. Dear winner, you have been selected for a prize for brand of new model BMW hydrogen 7 Series car, a check for $500,000, and obviously as valuable, an Apple laptop. Right? And you go, yeah. Right? And I have a whole bunch of those. I keep them. Right? We'll talk maybe about why any expectation that you are that you're too smart is wrong. The fact is that all these bad guys are organised, and the scale of the problem is horrific. Right, so you can see the numbers there, right, at the bottom. Right, 2016, cybercrime was valued at $450 billion. Right? 2016, same year, the illicit drug trade is estimated to be worth less. But that's think here. The value of the organised crime people are getting out of us is more than they're getting out of us buying drugs. That's how big it is. And it gets worse. What's the most profitable type of crime? Which one has the least risk to the criminal? Which one is growing the fastest? Which one is predicted to reach $2 trillion billion? $2 trillion billion by next year, and $6 trillion by 2021. Well, if you picked cybercrime, you were right. Let me show you. Oh, I forgot to run the screen. I don't know. Let me show you. Okay. That's really weird. Okay. No. I have a chart. That's the thing. What is going on? Okay, let's try. That's really strange. Okay. Let's see if this works. Time, trillions of dollars, cybercrime, drug trade. Just caught the effect now. There's the prediction. The drug trade is like bouncing around about the same value, plus or minus. But cybercrime was trivial until about 16, 17, and now it's going to look. Because we get them in. We are totally defenseless. So the $6 trillion is about $750 per person on the planet. Right? Are you willing to give these guys $1,000? Just take it, right? Because that's what it means. That's how just take it. Right? It's that bad. So now let's talk about, go back to the code, let's talk about the vulnerability. So I started with the vulnerability to show you how easy it was to make mistakes. And you saw how scary this is. People are exploiting this. So let's talk about vulnerabilities. So I have this directory used as school for, you can tell I'm a Mac user, can't you? Anybody got Macs? Oh, yeah, okay. Those of you who haven't got Macs won't get the joke. Okay, right, we'll forget that one. So there's a space. Right, and I want to refer it to URL, so I encoded it, and I put percentage 20 in, URL encoding to cover the space. Right? And then I've got some pseudocode here, basically create my URL, get a path from it, encode the file, print out where the path is and whether the file exists. Right, so bear in mind that path with the space in is a real directory. So I run it, and it says, yep, there's the path. Does it exist? No, because I left the percentage 20 in. Mistake. So, I added some code. URIs. I can convert that, so I can take URI.getPath. Right, so the code changes slightly, it's printed out. The result I get is path. Hey, it's got space in. Excellent. Does it exist? Yes. Okay? That's just a bug, isn't it? Okay. However, the code that failed at the beginning to say, does this thing with percentage 20 exist, failed because that directory didn't exist. Somebody could have created that directory, because that's valid. Right? And then when they ran that code, it would have been true, it existed, right? Because somebody got in there. Now you may not think that's a big deal, that's just a little bug, right? The thing is, if you couple that with the fact that on Windows, anybody, if you get access to a Windows system, you can create anything at top level. So make a directory, anything you want. It's a design feature. Right? And if that doesn't really get you, what happens if, through that exploit, I have something like this sitting in my extensions path or class path or any of those paths? Right? You don't know it's there because it doesn't exist. So when you search, you just go straight through. Right? But if somebody finds that, and I'll show you in a minute how they find that, right? They can create that. Right? So if you've got a couple with the fact that somebody can create a path on the root directory that matches something that's on your extensions path or class path, somebody can create that, and then you're searching. You know, you imagine you're going through resolving, have I got this jar, have I got this DLL, whereas before you were finding it in one place, suddenly, because you've now made one of those entries before that live, now I can find it somewhere else. Right? That's an exploit, right? Because of one missing line of code. Now the scary thing is, that's almost a real story, because that was a bug like that, not quite like that we had with JVM. And it got fixed and we found it. Right? My point is that there are no smoking guns, there are no big things, there are no comments in the code saying, this is a big security problem. Right? It's simple, little tiny things, right? And it's the collection and bringing them together by people who think that way that you get exploits.
What's the exploit? Can you go over that again?
Okay. You got a class path. JVM, you got a class path.
Okay.
Right? And you want to just load a class. If your class path has an entry at the front that doesn't exist on your disk, then when you're searching, the VM will go, doesn't exist, move on. Right? It doesn't care. If I can find a way to get that thing to be created on your system without you knowing, then when your JVM application tries to load something, I can now force you to load code that you weren't expecting, right? Because it's higher up the class path. Right? And the extension directories, class path, all the same. Extensions directory is great because I can load DLLs. Right? Yeah.
Could you do an experiment and mute your microphone? You purposely have a delay to prevent feedback, but we're hearing you twice, once with your voice and once with...
Do I say the same thing?
If you could just speak without the PA so you can understand you better.
Doesn't reach the back of it.
That's off. Can you hear me?
Yeah.
Much better.
Well, I'm happy. There's a row of seats at the front. Can you hear me at the back? You can. Okay, right. I'll just shout more and drink more beer. Okay, right. So did I answer your question?
I'm still a little iffy on it, but if most people got it, then I guess that's fine. I'm not sure if most people
Right.
do.
So just it's like in all searches, class pass and extension pass or whatever the entries are, if that entry does not exist, then no errors are thrown. It's just, well, you're allowed to put entries on class path that don't exist, right? Because, well, that's just history. So if I'm searching for class com.ibm.foo and I expect it to be in this jar file at the end, but actually some bad guy manages to get a jar file installed in a directory that didn't exist, so I create the directory and I put the jar file there, then the JVM will find code there first rather than when I expect it, right? It's just indirection. It's that basic problem.
So you're referring to a directory that didn't exist
Yeah.
when you expected it to.
No,
You
if you
specified a directory wrong, and so therefore it doesn't exist until someone makes it.
yeah, but that's true. And just to go back to this thing, there are lots of places where people have optional product extensions, and you can find places where VMs have configurations that are deliberately set up so that if you install the option later, you don't have to do some config changes, right? So it's deliberately designed to do that. Right. So now exploits, chain together vulnerabilities. That's the major thing to take away. It's these little things that get joined together by somebody who thinks about how they could exploit you. That's not the only sort of exploits that go on. Right? There's a whole social engineering thing that goes on aimed at us. And that's because we're the guys that write we know how things work. We write the code, right? We tend to run things with higher privileges. We are very trusting. And we run other people's code without even thinking about it. How many of you work for a company where you have a policy about consuming other people's code? Wow, okay. I was going to say, generally what we find is people have policies that check for licenses. What's the license of the code that I'm working for? Nobody ever checks to look for the provenance of the code that they're getting. So if you go to Maven Central and you get something down, you go Stack Overflow, there's a bug, somebody says use this tool, Apache Commons, whatever. You go Maven, you put it in your POM, it's installed. You might check the license, but the chances are you will never go to the website that created that thing to have any sense about whether this was a guy in his attic or it's a company. Or, what was your sense about the thing you're using? What did this company, what did this group that are using this, what do they tell you about how they manage vulnerabilities, right? We don't do that. We just use it, right? Because we're ignorant security matters. We just use code, right? The bad guys prey on the weak, vulnerable, ignorant, and that is us, right? And if you don't agree with that, let's look at it. Have any of you ever Googled for this, or words like this? Okay, I have to say, yeah, I've done it. We've all sat there, we've gone, we've got a self-signed certificate, talking to this server, what we're going to do about it. Let's just turn them all off. Right? We do it all the time. Right? We're not specific, we just go, let's just turn it off, okay? Or we might even go even further. I have to say, I put this up at a mixed Java and JavaScript conference, and nobody went. It was like, you're all JavaScript programmers, aren't you? Okay, so you're a Java programmer. The chances are you have seen code like this, you have written code like this, you have searched for code like this. Anybody not searched for code like this? Wow, okay, you guys need to get a life. You're not living on the edge. The most important bit, the last two methods, which says, is client trusted? Yes. Is server trusted? Yes. Okay. Everybody at some point will think about doing that. Right. Well, we've all done that. Blah, we do it all the time. How bad can this problem be? Right, okay. Let's do a GitHub search for implements trust manager. Would anybody like to guess the magnitude of the number of hits that I got back?
6 digits.
Way. Not quite. This was, I updated this with DevNexus, so this is pretty close.
I don't know.
103,000. Right? A very friendly, accepting trust manager factory allows anything through. All kinds of certificates accept and trusted. This is words that I find on GitHub. Does that make you feel happy?
Yes.
Let me tell you that this isn't all in demo code or developer hacking. This is, and some of this is in open source products and code that you're using. Right?
Could potentially this code be in like the test directory, like the...
Oh yeah, it's everywhere. I mean, 100,000, you'll get it in every single type. There'll be tests, which might make it legitimate, but there will be open source projects where people have done that and created a component that somebody else has used. It's just...
I mean, there's a test directory in your that could be, like for automated testing, it's still part of your branch. Do you exclude those?
No, I just tasked GitHub. I wasn't expecting that sort of number. Right? And the takeaway is we can add to the list of bugs, features, design things. So vulnerabilities are not only bugs that we accidentally put in there, they're also things that we did deliberately. Right? And there's a whole bunch of guys out there looking for them. Okay, so your mistakes will be found out. Right? Everything. Everybody wants to find. There is an arms race going on, if you can call it that, between the researchers who are actively trying to create exploits. They're looking for all these vulnerabilities, these small changes, joining together because they need to find it quicker than the bad guys do. Because if the bad guys find it, then you're broke. Well, at least if the researchers find it, there's a hope of fixing it. Right? It is happening right now, all the time, at a very accelerated rate. Right, okay. So because this is an anatomy talk and it's going to cover everything, I do have to talk a little bit about how they get managed. So at least you get what happens on the, once we've discovered one, what do we do with it type thing. Right. So, vulnerabilities are actually called CVEs. That's the term that you'll find, common vulnerabilities and exposures. There is a website, it's not the only one, but it's the primary one, where all these vulnerabilities are recorded. The important bit is, if we can't talk about it, then it's hard to have a conversation about whether you've got it fixed or not. So we have numbers, right? Right? That's basically the main thing. Regardless of whether it's Java bug or CVEs for everybody, right? Everybody talks about CVEs, whatever it is, operating systems are. Right? And you can go there and you can search. So this is, the number's probably about a week old. There's a couple of searches here. One is for Java, which is that one. This one was Java and serialization. And you can see numbers and words and stuff. Right, don't worry about the numbers because everything's out there. Anything you can think of, excuse me, you can go search. And you'll get really large numbers or really small numbers. It's just the luck of the draw. The top three from the serialization list as of May the 11th were these ones. Okay, you can see some common words that come up. Okay. Nothing that tells you too much about what's going on. This one, unspecified vulnerability, tends to indicate it's even more painful than the others. Right. And basically, if you look at these things, that's what you're going to find. You're not going to find anything behind that. That's all we're going to tell you. Right? There is a good reason for that. Right? What would happen? Let me give you an example. Right. Let's put the words up. If I was to say to you, here's all the details about the CVE, about how to exploit the vulnerability, it is very much the same as me tweeting my credit card and PIN number. I've given the bad guys all the information they use to make use of it. Right? So the best we can give you is hints, where it's affected, scores, impact, and stuff like that. Right? And impact is done by this thing called CVSS. What can I tell you? We'll go through quickly what it covers, but basically we're trying to figure out what the impact is for a whole bunch of criteria. And the most important thing to take away from this slide is it changes. Just because today we don't think it's important doesn't mean tomorrow we suddenly change our minds, because things change, environments change. It gets suddenly this vulnerability's got some aspect of it changes. People realise a bit more about it. Anything can happen. So it's not like you can just go there once and go, that's it. And this vector, this set of things that tells you about that vulnerability without telling you about the vulnerability, has all sorts of pieces about it, right? You can guess what they are. They get summed up and you get a score. And if it's really critical, obviously we need to fix it. Right? We tend to expect that the people who are reading this run their systems in a reasonable manner. If you run your system and you give everybody root access or whatever, then all bets are off on your own. You'd be surprised who does that. Right? So having figured out some scoring system and a communications mechanism and a way for us to track them so we all know what we're talking about, even if they're hidden, Oracle puts out CPU advisories, IBM does the same, there's a whole bunch of, you can go find this stuff. And it's not just for Java things, it's OSs as well. Right. Now, if you discover one, which possibly you might think is easy, but it might be quite hard because it doesn't take much of a piece of code to make it a vulnerability. Right? But what we would ask you to do is report it sensibly. So if you know, you can report it to Oracle. You can take the links, but basically it's fairly self-evident where to go. Please don't tweet about the fact you found a vulnerability. That's just not a good thing to do. Don't send a mail about it. Keep it quiet, right? And don't sell it to the bad guys. I can't stop you doing that, because if you're that way inclined, you're that way inclined, right? But even if you're not sure, right? If you go, well, possibly, right? You just report it. What's the worst happens? We go. They go, thank you very much. Right. And then what happens when we've got them? We're fixing them. Well, Oracle, IBM, whoever, engineering teams, they have finite resources. So whether it gets fixed or not is dependent on the score. It's definitely dependent on whether we've got the resources. It's also dependent on whether some researchers got so fed up waiting for it to be fixed that they say they're going to publish it. And that tends to, get the monster companies up and running. Right? But as you can imagine, it basically means we'll fix it as soon as we can and in a regular process. You know about the CPU updates. If you get an out-of-cycle CPU, that means there's a really bad thing in there that you need to get fixed. Right? Because we're not saying it otherwise. So here's the rub. There's these scores, and everybody says, if the issue doesn't apply for you, don't fix it. My experience is you don't know whether this applies to you. Right? Now you might get some obvious things like JAX-P, and you go, I don't use JAX-P. And you go, fine, don't need that fixed then. Right? However, my assertion is, you don't know what your dependencies are because you blindly install them. And if you don't know what your dependencies are, you don't know whether you need that fix or not, right? Because you don't check. You just use code. Right. So, let's talk a little bit about how people attack us, what they're trying to do. It is a bit dry, but it's sort of for completeness. There are a series of things that people are trying to do. Untrusted code, can they find a way around the security manager? If you run a security manager, can they find a way around it? Right. One of the things that they do is they look to see what code you've got installed. And you make it, how can they find out what code I've got installed? We'll talk about that later. Right. But basically, if they can find out that you've got some code installed, and the code you've got installed has got a particular vulnerability, right, for running code, then I can figure out how to call it. Right? And believe me, there are lots of ways of getting code, calling code. Right? So you can imagine, it's basically, can I get some code? Can I run some code? And it doesn't necessarily mean that they're going to insert code. They're just going to find code that you've already got that you didn't know about, or you hadn't realized what the vulnerability was. Okay. And then there's the ubiquitous plug in a web start, which, much as it says is going away in Java 9, woohoo, right? Not sure how long it's going to take before it's actually gone. Does anybody use plug in a web start? Oh, right answer. Cool. The brain problem was it was just very poorly designed, so it had lots of intrinsic vulnerabilities, and it just wasn't fixable. So it just became something that, well, we don't need it anymore because people have got better ways of doing things on the web in terms of making things move, and so effectively it's just not worth it. Which is a shame because I thought JNRP was quite good. Untrusted data. This is fun, right? One of the number one thing that applications do is they fail to validate their data. The data comes into the system, right? And you make some assumptions that it's valid. The interesting thing is that depending on what problem it is, I can send you data to make all sorts of things. You saw at the beginning with the double, right? There are some other examples, right? But that's basically I can get stuff in, right? And it's like XML, SOAP, even images. There was a bug, a vulnerability, in the JPEG 2000 implementation, well, OpenJPEG, which meant that properly crafted, I can send you an image which has a nice pretty kitten in it. Oh, ding, I score. And tucked in the back of it was some horrible code. And the buffer overflow in the native code. So again, just bear this in mind. You run Java, but underneath this is always a bunch of native code. Right? There are runtimes, there are all sorts of stuff that we just use that are written in C. And here's one, right? So the nice kitten comes in, and what happens is the buffer overflow means executes random code. Well, not arbitrary code that this guy set up, right? Validation of your input data is expensive, but if you don't validate, you run the risk of this. So input data is not just the text that comes back from when somebody presses post on the submit on the form. It's anything. Right? Here's another example. This is a real problem, right? I don't normally talk about it in detail. You can go read all about this one. So I'll try to explain. Content type. How many of you know, use, create, run web servers? Okay, cool. So when you send data to, if you're doing a submit, then you're sending data back, and part of the content that you send back is there's a bunch of keywords, content type, right? Because in this instance, it says multi-part form data. Now, if you know what it should look like, you realize that this doesn't look anything like it. Content type is valid, but the rest of it is all rubbish, right? But you can see that there's a sense in there. So what happened? Well, Apache Struts basically said, got this piece of data in, and it just said, does it contain that string? Doesn't matter whether it's valid, does it contain that multi-part form data? And it was, yep, that's true, it does. So it assumes this should be of a certain form, which it isn't, and it tries to parse it, and the parsing fails because it's not valid. Right? Now, as part of the failure, the Apache struts probe, really weird thing, as part of the failure, it tried to execute it, right? Because it had spotted that it's OGNL. That's a scripting language, so this is a scripting language, right? So as part of the failure, it ran the code, and this is real code as far as it's concerned. That's a string which gets ignored, some blah 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 stuff, Java lang runtime, get runtime, exec, whatever you want, or anything really. Have a guess which little company this might be. Ta-da! Now the good news is, at DevNext as I did this, and afterwards the guy said, I work for Equifax, and I said, did I get it right? He went, yeah. Right, there we go. That's a vulnerability because they didn't validate the data. Right? Yeah, so we all know how horrible Equifax was. The really horrible thing is that there are still hundreds of thousands of servers out there running the version of struts which has got this problem in it still. And they're all vulnerable to this. So, other attack vectors, cryptographic ones. This is horrible. There are lots of implementations of cryptography, and occasionally they get some bug in them. We hope that it's a bug problem, an implementation problem. Unfortunately, occasionally we find protocol problems, and if you have a protocol problem, then we're totally stuffed. Chuck the protocol away and do something else. They have nice names, not necessarily because they're protocol problems, but because we can talk about them. These are great, right? When I was in the DevOps team, these used to come through and go, hey, we're dealing with Poole, or Heartbleed, or whatever, right? The point is, even the little ones are really critical because of the consequences of it. There are implementation flaws, so you get Java stuff, they're just bugs, right? We just fix those as soon as possible, right? Cryptographic issues, obviously, if there's a break in your encryption, then we can get your data, right? We might be able to steal your keys, which is another one of those where basically you ended up being able to give away your private keys, which is excellent. Or you can deny service attacks because some of these things have those sorts of high CPU costs. Right? So people are trying to break through that way, right? And then they're trying to get onto your system. Do you feel threatened yet? Right. Yeah. So local attack vectors are all the things you can think of when somebody has access to your system. Install code, run things, right? Whatever. If I get access to your system, I can do bad things, right? And these don't get high scores because the assumption is people very rarely can get access to your system. However, people think that their local systems aren't that easy to get hacked. But actually, I don't even have to hack your server. I just have to hack you. Right? Anybody know what this is? Yeah. You guys have poor memories. Go on. Okay. Huh? It's this thing. WannaCry. This was a piece of code that got delivered to your system through a bunch of OS vulnerabilities that encrypted your data and then charged you some money to get it decrypted. You can buy payload delivery systems. You go to the dark web and you can buy all sorts of ways to get code onto your system. Right? And if I can get into your network, then those systems can find other vulnerable systems and install them. That's what WannaCry did. Right? Once it got in, it went everywhere. Right? WannaCry was at the time probably the most horrible thing we'd had to deal with. In the UK, our house servers got impacted. India closed all the ATMs. Well, you can read Nissan and Renault, production problems sorted. You can see it just hit loads of people. And the horrible thing is that some journalists managed to reach out and find the guys who did this. It's an anonymous conversation. And those guys said, yeah, it wasn't much of a success. We only made about $85,000. How do they get paid? Through Bitcoin, anonymous Bitcoin. So it's untraceable, which is one of the reasons why ransomware is growing so much, is because the ransomers can have a sort of a, they can just be paid anonymously and there's nothing that anybody can do about it. Right, $85,000, which was about $3 for every one of these. You can imagine the millions and millions of dollars it costs. And this is just the beginning. You saw that curve at the beginning, more of this, more of everything. The takeaway is, don't think that your production systems are secure, because if you as an individual is not secure, then they can find ways to leak from there to your server. Right, more code examples. Some of it quite complicated, so there's no code. Who uses serialization? What I normally say is if you didn't put your hand up, you're wrong, because everybody uses serialization. Right? Serialization is not something you can opt out of. Your application gets opted into serialization without you knowing about it. So I said about the fact that people can look into your class path and find things. People create these things called gadget chains, which is one class being able to go another class, go another class. Right? Serialization has a basic flaw, right? Which is you can have objects. And I can construct a serialized form which says, so if you have a class that has an object field in it, then at the point that your object, that the instance is deserialized, and it says read object, so it's going to fit it in, anything can be added. So if somebody hacks your serialized form of data form, they can insert anything, right? Just because you said, I've got an object field, right? And there are problems like them. We've known some vulnerabilities like Apache Commons, but everybody has these sorts of problems. Serialization is a big problem for once you get into the data flow, then I can hack your data flow, then I can make your system do anything because I can call any code that you've got. And of course I can manipulate your data. Now, there was a little hope that filtering coming serialization, so whitelisting, so you could actually say, I only allow certain classes to be instantiated. That doesn't help if you're some sort of middleware. It gets a bit complicated, right? There is no simple answer. And then another example, this is more an example of being stupid, right? JDWP is the thing we use to do debugging. So when you have a remote server and you want to debug it, well, you might leave the debugger open, right? And then you can connect. This particular example is where some particularly very large bank did that, but they ran it in the cloud and they left the port open and it was publicly accessible. And so some nice little researcher found the port, connected to JWP, had full access to the complete contents of the VM that this bank was using, right? Right, and he got paid because he pointed out and they gave him some money to shut up, right? So, my point is, even our development tools can be used against us, and if we're not careful, right, that comes back to bite us. Right. Okay, so I said about how people get into your system. How do they find out about your system? So more code. What can I say about this? Okay. So imagine, this is a common example of where you have some map that's going to map some handler to a class. You want some system where you say, I need the class that's going to implement some interface to deal with this thing. So this is quite common where you have, I don't know, say XML where you have data types. So you're going, I've got a data type and I want to get the class that instantiates that. Okay, now you could put the classes in, but a lot of people would do something like this, where they would basically have a map. Okay? And as you can see up here, they backed this properties file with system.getProperties, which is really useful because then you can put -ds on the JVM on the command line and add new classes. It's just easy. Rather than have to change code or write files, you can just put -ds on. Right? So here's a piece of code that makes use of that. So basically, it's going to get given this handler, and it's going to go off and find the property, and it's going to try and create the class and return it, right? And if it doesn't work, it'll throw out and say, this handler, this value. Okay? Very common set of code, similar things like that. So, if I call it, and I say, let's load default. So the little table at the top tells you what's in the properties. So loads default, system print out class of default. So what you'd expect to see is foo.string handler. Ooh, let's run it. Or soon run it. So yeah, class for default equals class.foo.string handler. Didn't go wrong, no exceptions. Okay. So let's try foo. Okay, well in this case, that class doesn't exist. So when I try to run it, I get the exception. Class not found exception, could not create class for handler foo with value, compile items at runtimes.demo.field. Okay? Now, what's wrong with that? Nothing. That's fine. Piece of code. Does stuff. What happens though is if I can convince your code to load a class that's called java.axt.does. So if I want a handler for java.ext.does, right? Now remember, this class, this property is backed by system properties. So what's going to happen? Any guesses? You bored already? Want more beer? Okay. What happens? You get an exception because that's not in the table. It's not in the properties file. It goes to the backing system get properties, and it pulls out the long list of directories, and it tries to create a class for it. And that fails, as you'd expect. But very handily, it lists all the entries in the extensions directory. Got that? So just by being helpful,
The value of the
did I do that all right?
probably right. That's different.
Well, see, the principle is, I can now come to your system and probe your system properties by using this piece of code and just asking you to instantiate something that doesn't exist as a class, and I get back all the information I need because I was being helpful. Right? And there are lots of similar examples out there where people are returning helpful diagnostic information that unfortunately gets exploited to give away stuff that I really shouldn't be giving away. Okay. So I can find out what's in your class path. So WannaCry can get me code in that I can use to call and find information about your VM. I can do things like URL decoder bug. I can install code. Right? I can compromise your application completely in multiple ways. So I can add to the list developer aids, because every time as a developer you make things easy for yourself, you're giving these guys more information to hack you. Right, so that's the scary bit and the code bit. What can you do about it? Well, you can shut your laptop and never touch a computer again, right? Run for the hills, and there are times. But there are practical things, and it's all about being educated, right? Because unfortunately, as a developer, we don't think that way. We don't really understand what's going on. So there are lots of things you can go learn about. these are not all necessarily the greatest, but there are people trying to solve the problem and help us. So CWEs are basically examples of how not to do it. Right? And you can go find all sorts of information of common coding patterns that say, and it says don't do that, do it like this. Right? So trivial things like don't hard code passwords, right? Which you might go, well, that's obvious, but you'd be surprised. Right? And they give you examples like this. Right, there we go, look, if Stracomp password is mute, then let them in. Right? So there's a really good website to go do that, to go look. Right? And it will help you think about, right, how about it. So your challenge going forward is that you've got to think more and more from the point of view of being exploited. What are you doing and what's the risk of it doing? Right? If you don't validate data, if you share information, what's the risk? Right? So these are common weaknesses. They have this thing called the 7 pernicious kingdoms, which is basically the categories of the types of problem that you could be adding to your code. It's a really good place to go. It's not perfect for sure, but it's a good place to start reading about it. Input validation is the number one. Everybody says if you validated your input to your website correctly, right, fully, 99% of all the hacks disappear. People just find ways in. Right? There's secure coded guidelines for Java, which is dry, but it's again more notes about how you should do things so it's more secure and what not to do. Right? I won't let you read the words. There are tools coming out that are starting to take these patterns and apply them. So I was playing around with this at LGTM. Right? You can connect this to your GitHub public repo. Right? So this is scary. So this thing is a tool that understands more about the code patterns that are considered to be non-optimal, and it will tell you. Right? This is not a particularly useful one from a security point of view, right? But right now, here's the really bad thing. If you're an open source project, somebody could fork your repository and apply this tool to that repository and find your vulnerabilities before you do. Think about that. Right? There are other like find security bugs. So if you've used find bugs, same sort of thing, some tooling to allow a tool to look at your code on your desktop or whatever to give you some hints that what you're doing is not optimal, you should be thinking about coding it differently. There are loads of online guides. I point at Owen Woods because he takes a higher view, because there's this, we can talk about it from a coding point of view, but one of the things you have to take away is it's like, well, what should I do next? What's the most important thing? So how do you assess your situation? How you take risk how you do risk assessments? What should I do next? And Owen's got some really good stuff about how to do that. But to be honest, there are lots of information out there about how to think about your problem. We're just not doing it. And there's OWASP. OWASP is a community effort that lists all the top types of vulnerability. Hey, guess what? Injections at the top. But again, not only do they tell you more about it, OWASP has they have some great projects like insecure websites, so you can go run them and learn them and hack them. There's lots of stuff out there to teach you how to think about the problem. Right. So, where look at that. Summary. This is all about reducing risks, right? There's the obvious, as I keep saying. If you receive data from anywhere, if you're doing microservices, then you're talking services, right? Every time you communicate with those, you've got to validate the data. Is it what you expected, right? And you saw with the JPEG how obvious it is. Like, well, some of the stuff you're going to go, how would I validate a JPEG? Well, sometimes all you do is you go, have I got the latest code with no vulnerabilities in? That's your mitigation. There are lots of vulnerability scanning tools, right? You can go. They're just coming out of the woodwork for scanning your dependencies, Docker images, VMs, whatever. Loads of them are out there, right? They do source code to binary. There are tools out there. If you've got a bunch of fat jars, for instance, where you're not quite sure what's in it, there are tools that can scan the fat jars. They can find the vulnerable code for you, right? So there are lots of tools. You just got to start learning about them and making some decisions. There's some don'ts. Don't do any of these, right? Use what's out there, because A, if bugs get found, then they can get fixed, right? Yes, you run the risk of picking up somebody else's vulnerability, but you get more confidence from using something that lots of people are managing and keeping up to date. If you write your own stuff, especially your own crypto code, right? Just so often people think they know what they're doing, and that's not a good idea, right? Untrusted data, right? And if you code runtime.exec in your application, why? Right? Have a good look at what you're doing and saying, how often am I doing this for me as a developer, or is it making the application that I'm producing better? And make sure you get the right answer, right? And things like, and don't forget, this also applies to native code. It's in your hands, right? We as developers have just turned a blind eye, right? Well, the world to a degree has turned a blind eye. We've seen things from what people are doing, trying to hack systems, influence elections, and that sort of stuff. And so much of that comes down to they're talking to some piece of software that we wrote without any of this guidance. We wrote it as a developer, not thinking about all the bad things could happen. Right? So the good news is some of the stuff we're doing, in terms of microservice architectures and things, which we weren't doing for security reasons, makes life a bit better. If you're doing continuous delivery and you've got microservices, then it reduces your risk of keeping things up to date, because updating patches and things, everybody goes all, it destabilizes. Well, do you want to be destabilized, or do you want to be hacked? Your choice. Right. Go learn penetration testing. Go learn, and there are lots of tools. You can go, OWASP have got some really good education. You can go see what the guys who are hacking your system, the white hat guys, do. And then you'll be shocked, because you can buy all sorts of tools already that will help give information about your system away. But at least you know what they're going to do, right? Security scanning tools, etc. Yeah, there we go. I think I've said that, right? Understand that making your life easier is another way of letting people in. Right. And that's about it, really. I don't know how long we've got. I have another talk that goes about cybersecurity in more details, but it's more about scaring the hell out of you. Any more questions? Any questions? Does anybody? Yes.
Is Watson being trained to look for?
It's even worse than that. So AI, Watson included, there are AIs being used to figure out how to defend, but also attack. And there are in fact competitions being run where you have AIs on both sides trying to defend and attack systems. Right? So yes, AI is being used to attack you just as much as it's being used to defend you. Yeah. There are just times when I just go, I'm just not going to do this anymore. Right? I'm going to take up painting or something. I'm just not worried about it.
Is it a mistake to acknowledge the open source contributions in your project, say on an about page, or is it to expose the software you're using in a URL?
Well, let me show you something. Just stop this, because this is interesting. Let me bring it up. Oh, of course, it's on the wrong page. Oh, no, it's okay. So let me just show you. If I get it right. That one, I think. Right, so this is a browser plugin that's run by a particular company called WAP Analyzer. Right, so what this is, this analyzes the data that's come down from the server, and it works out what you've got. right? It's really scary. So your choice is, if you could not acknowledge everything. You could just go, I'm a black box. But it leaks, right? It just leaks. I mean, this is a really innocuous one because it's GitHub, they know what they're doing. There are others that are very specific. You could argue that you should never use open source again. You should buy code that people don't put on GitHub, and that they just custom write for you, because if you've got a variety of code, then there's less likely to be hacked because people aren't finding the vulnerabilities. So you could say, batten up the hatches. Let's keep it all closed. Get rid of all open source. It is a possible way around this. However, from what we've seen, it isn't the open source is obvious vulnerabilities, but so much of it is to your data validation, and that tends to be your problem, not your open source problem. It tends to, right? So on the terms of talking about stuff, well, it all gets a bit horrible because when you look at what the bad guys are up to do, how long have we got to talk? Have I got to talk?
I think we can go over an hour here with questions.
Okay. Well, so let me bring up another deck because it's just to show you. I will just use it to remind me because it's just a bit scary. So I did this talk in Poland about this other people in this open space, and in this sort of vague sort of mole. It was a bit weird, and it had staircases. By the time I'd finished, everybody had stopped. Everybody was looking over the stairs at me because I was doing this talk, and it obviously resonated. So let's whip through. What I'm going to show you is not about me, not about that. Blah blah blah. Right, we did all those. You've seen that one. You've seen that. So, bad guys. Who are the bad guys? First thing to take away, they're organised, but they're developers. They're learning. Right? I always say, go to any user group, one of you is a bad guy. Because they come and find this stuff out. Right? They're incented, as you can imagine, to come and learn this stuff from us. They go to conferences, right, and they write code. Right? They're mostly already into crime, which is a good thing, because it means that that's how we catch them. People committing cyber crimes almost invariably do not get caught for committing cyber crime, unless they're really stupid. They get caught because they were doing something else, right? And that's the horrible thing is that, well, okay, you're a drug dealer, you steal cars, and you do a bit of cyber crime on the side. Right? They're after a whole bunch of information about you. Right? They want long-term identity theft. So often you're not going to know you've been hacked until it's way, way too late. Right? And they want to know how you behave, because your behaviour tells them how to get into your company's website, into your company's system. Right? So they want to know any bits of information. If I can connect your email to your date of birth, right? So I had a bit of identity theft a couple of weeks ago. Got this email about insurance on some large van, which I went nothing to do with me, mate. Had my address on it, the credit details. Had nothing else right. It was just my home address, which is public because it's that's just the way it is. But if they could have found my date of birth, then all bets are off, because then it would be my address, my date of birth, email address is wrong. Banks don't care about that, right? And they just get together. And things like Ancestry.com allow me to search for people. So okay, how old is he? Where does he live? Oh, look, that looks about right. Get date of birth. Find out who your mother is, possibly. So mother's maiden name. Hey, right? Who you work for? Okay. Go to your Facebook page where you're moaning about your boss to your friends, but you're doing it publicly. yeah, so you can see where you've been if they can, right? They can figure out more about you, so they can tailor attack to make it more personal and less likely that you'll spot it, right? So so you've seen lots of the phishing. I mean, these are all ones I got. You know, you've all had these things. They just come through all the time, and we just laugh. Yes, right? Federal Bureau. This one was lovely. This one says. This is due to past corrupt government officials who almost held the funds to themselves for their selfish reason. You know, and you just laugh. Right? And the point is, and this one, this is a classic. This is the sort of things you get a text, right? And it's the don't distract me. If I know that you are frightened of your boss, whoever you are, then I can send you some information that looks like you've got to do something now and be happy that you're not going to check it. Right? It's really scary, right? This is a real one. This is where it gets real in that this is a document that looks correct because it's constructed by people who know what it should look like, because the guys doing it understand the business, right, and are IT savvy, and they just target your non-IT people who go, yeah, that looks about right, especially if they're busy, right, and then they get their code in. What was I saying here? Yeah. So the point is, just because you've seen all these phishing attacks and you've gone, ha, I'll never fall for this, that's because they're aimed at people more gullible than you. Why would I want to have a conversation about trying to screw a few $1,000s on somebody if they are going to spot it? Waste of time. So put out the greedy and gullible ones and string them along, get the money. Right? If I'm trying to get you to fall for it, I'm going to tune it to you. Right? We've said all that. Yeah, blah, 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 blah. You've seen all this horrible stuff. Yeah, so there's the old-fashioned ways, social engineering. You just let them in. Vulnerability exploits we talked about. Information insiders where you sell. You just go, I don't like my company, give me some money, right? They're already doing that. And then there's how good is your network? How many people have got printers installed on their network? How many of you understand what you've got? You've got a device with a computer in, which is attached to your network. Many of them don't have default passwords, so even if they're legitimate to start off with, they can get hacked. People can install software on them, right? Drive-by gateways, we'll talk about in a sec, ransom. Malware into real products, Docker images. Hey, there's a Docker image for just what I want. There's a package for just what I want, right? But you take it in and it's really helpful, and then it does something more than you wanted, right? Especially with Docker, right? If you ever get anybody says to you, here's a Docker image, please install it and make sure that it can mount root directories or something, you go, no. And if it says mount your home directory, you go, no, right? Anyway, there are a whole bunch of ways these guys are getting in. Okay, so so what's inside your thing? Smart TVs. I love this, right? This is a thing called a system on a chip, SOC. Right? It's in the loads and loads of anything, smart TVs, printers, whatever, right? Lots of people don't actually know what's in them, as in they get bought, right? So I'm doing this talk, and this guy comes up and tells me a story, and I tell the story somewhere else, and somebody else comes up and says, that happened to me too. So here's the story. Company in the US, middle of nowhere, buys a smart TV. It's only got Ethernet capability. Plug it in the wall. Ta-da! Great, fantastic. Later on, they find out that they've gained a new SSID. It just pops up. Okay, they're in the middle of nowhere, so they're a bit confused as to where this thing has come from. And luckily, eventually, they realise it's the TV. So they find out the TV manufacturer, because they're an engineering company. They go back and they go, your TV does this, how do we turn it off? And they go, our TVs don't do that. Right? So they took it apart. And they found a sock, right, which had a Wi-Fi chip in it. The TV company goes, that's not what we ship, right? So somewhere between the factory creating the TV and it ending up in this company's location, it had been physically altered. Now the chances are, to be honest, it was done at the factory, right? Because it's easy. And it gets even scarier because when they turn this thing on, so it's now connected to your network and it's broadcasting a Wi-Fi SSID, it phones home. It has some basic understanding of where it is in the world, phones home. So worst case, somebody comes along with a car and a laptop, right? Comes to your location, connects to the Wi-Fi and now into your network. Right? That's how scary this is. This is the sort of things guys are doing to get into your systems. Do you know about HTTP hacking? Okay. If your website ever puts up an HTTP page rather than HTTPS, you're dead. Because if you have HTTPS, then at least you're having a secure conversation. If you have HTTP, you're throwing data in the clear, right? Yeah, I said that, right? If you have a man in the middle, which you don't know about, when you flow data in the clear, they can steal it. How many of you here are connected to the local Wi-Fi? I know I am. How do you know that local Wi-Fi is legitimate? It could be anybody, right? And if you go to a conference and they publish the passwords and stuff, it's even multiple legitimate. Right? It's easy. Yeah, right. So what I can tell you, right. So you know, we're all used to getting websites where we connect to something and it goes, oh, the certificate can't be trusted, right? And so many of us go accept. Right. What else can I say? So sometimes that stuff gets installed. Here's the horrible picture. This is real, right? So the thing in the middle, the Wi-Fi, you don't know when you connect to a Wi-Fi wall who owns it. If you go to Starbucks, or just because it says Starbucks doesn't mean it is. Right? How do you know? In fact, so I have pictures, but I'm running out of time. But I have at home a little grey box that's an electrical conduit box that will not be out of place anywhere. And I have a Raspberry Pi and a power supply, and I can just plug it on the wall, and it does a Wi-Fi rebroadcast, right? So you connect to my thing, and then I pass you on. It could be anywhere. You would not know, right? And what it can do, it has some software in the middle, right? It sniffs all the stuff going backwards and forwards. If you visited a website that had a landing page of HTTP, so it's in the clear, one of the classics is, so HTTP, you get back some HTML that's got a login form, type it in, press submit. Okay, and the post, when you press the form, it says the URL that you to post to is HTTPS something. So what the man in the middle thing does is it drops the S. Comes to you as no S. You don't know. You put the data in. You press submit. So now I have your password, user ID and password in the clear. I'm in the middle. You've sent it to me, not to the server. I take it, and then I send back some reason, server unavailable or whatever, and you go, oh damn, reset, right? And I'm out the way. And then you can just carry on. I've stolen your credentials. Just like that. And there are other variations of this where I can break into all these things. And if you think that, well, if I go to a conference and there's there'll be loads of routers for that particular SSID. The Wi-Fi protocol allows me to make you connect to my system. I can force you to disconnect and reconnect. Okay. So we settled that. Yeah, blah, blah. Okay. Yeah, right. And we just do it. Yeah, that's the scary stuff. I can point out that one of the other things we do is this. is we turn them off. Having said how important security checking is, developers are really good at tearing them off. Right? What can I say? These guys are out to get you, and they're organised, and they are watching you. So you have to look at all the information you put available. So for instance, if you have a company that's very proud, say you're a consultancy company, you put up a list of all the companies you've worked for, that's a really good flag. Because it says, if I can hack your system and get into the emails of your CTO, I can send emails to some of your clients and it'll look more legitimate, right? And these are what the guys are doing. So just because you're a small company doesn't mean you won't get hacked, right? It's who you know, what you do, what access you have that can get you into all sorts of trouble. Okay, I'm really depressed now. What can I say? This is reality. You saw the numbers. I mean, it's like, what do? Well, you just got to start learning about this stuff, and you've got to start thinking like the bad guys. Right? There is no option. It's not going to go away tomorrow. It's just going to get worse until we get a handle on it and start thinking how we're going to solve it. God. Sorry, I don't mean to be a downer, but that's what it is. Any more questions that I can? Yes.
So from a longer term perspective, I took a thing called the Google Secure Data Connector and kind of tried to turn it into a standard. Went through the rigmarole of writing prototype and request for comments, and I never got any comments. Are you aware of any architectural groups or places that I could submit that to get comments? Essentially what I'm trying to solve is the dial-in problem, adding a redirect, or like a middleware.
Not off the top of my head. If I tell you that we're still arguing over what a secure application design looks like, now with microservices, we are way behind thinking about it. So no, not off the top of my head. It's almost like the wrong way around. It's almost like nowadays, if you want to learn about this, stop being a developer and go being a hacker, go join Pinterest, and then you'll find out the groups that are active about solving the problems. But they tend to be, as far as I can see, they tend to be almost all ops guys, and it's almost like they don't talk to developers because we just don't get it. Sorry. Yeah.
Briefly going back to open source, OpenJDK, Oracle really pushing hard from IBM, pushing J9 to open source.
Yeah.
What are the security implications of that? There's always going to be this period in between the fix being merged, everybody having rolled out.
Well, that's the case anywhere. So what do you expect? You'd expect the people committing the changes to have a good understanding of the security implications. I'm not sure how you measure that, but we work by obscurity. Right? That's basically, if you go to any product, any open source product, you won't find the diff that says CVE blah blah blah. It'll just be some change. It gets hidden, and you have to figure out. And bearing in mind just how innocuous some changes that are vulnerabilities actually are, unless you start scanning through every single change and working it out, you might mix it. But not to say it's not impossible. If you get a CVE come through, you can go back to the website, you can probably find out a few changes within the range of the dates, and then if you're really careful, you can figure out what the change was.
Won't Oracle and IBM be releasing their own commercial version that contain security fixes?
Well, so the supported versions, yes. There's a conversation going on about how much on the non-LTS there, how quickly they're going to do security version fixes. I think at the end of the day, if IBM, for instance, doesn't get a satisfactory story, we'll be doing it ourselves. But LTSs will have full security support. It's just what do you do about the interim ones? But yeah. What can I say? The downsides of open source is people can go see what the source code is. The positive side is that you get a much bigger community working on the code base and getting things fixed and getting it innovated. So it's your choice. Yeah. God. I feel like I should be doing something to cheer you up. Like it's all a dream. Bobby's in the shower. Wake up. Yeah. Okay, no more questions? Okay, thank you very much. Oh, I didn't see you.
Yeah, sorry.
That doesn't do anything. I'm deaf out design.
So this is more like probably a cultural question than anything. Say you've identified, some subset of vulnerabilities via like app scan or whatever.
Yeah.
And you're trying to change the engineering organization such that, like, for instance, struts. You're using this old version. We should upgrade. You say to the engineering team, and you get a response. And the gist of it is, well, we're using a version of struts older than that, so we're not vulnerable.
Wow.
What do you like? How would you approach that? I guess.
Well, first off, go find all the vulnerabilities in the version that they have got.
Yeah.
Right? And if that's not easily listed, there are loads and loads of tools. If you've got, even the Docker guys now, with Docker containers, they offer a service to scan it. So all the cloud guys offer some service to tell you what vulnerabilities are. You could consider getting to the point of going, well, we can't deploy if we've got vulnerabilities. I think the challenge is that you've got to explain what the problem is. And for some reason, it's really weird, for some reason we don't take it seriously. We're talking about things like, Russians trying to hack the election or interfere with the election, and you're going, and that's just one system. It's really scary. I don't understand why we're not taking it seriously, and why every electronic system that's in your life is written by people like us who don't know about security. So basically it's time to run for the hills and go back to peace and payment. But I don't know why we don't take it seriously. It really bugs me. So a lot of it is, I can't put that vulnerability patch on because it destabilizes my system. Well, we have to run tests. So the only other answer I can say to that is if you're doing any sort of continuous delivery, if you're doing microservice architecture, you're working towards repeated updates, then that's where your testing should be. So you should be able to apply patches and test them without the onerous activities that you in the old ones. But if you're not doing that, and you're just going to do a full test, you've got to decide what the risk is, which is getting educated about where your company's at risk. I go learn more. Any more? Cool. So thank you for the opportunity to press the hell out of you. If you have any questions, or just reach out and I may answer.